Welcome back, mathematicians. It's Justin again. In our last lesson, we gathered data from 30 people in our representative sample for the statistical question, how much time do people in this town spend on any physical activity each week? So, what do you think? How much time do most people typically spend on physical activity? There are a lot of numbers in this table. We have the number we assigned each person from 1 to 30 and the number of hours they each spend on physical activity. We're really only focused on the hours of physical activity here, though, so let's remove the first column so it's less distracting. Now we just have the list of hours spent on physical activity. Do you notice any trends or patterns? I don't know. It's hard to tell because these values aren't in any particular order. Any ideas on how we can order this better? A good rule of thumb is to organize these numbers from least to greatest. Okay, and that's all 30 values ordered. It looks much better already. We are one step closer to analyzing this data. Looking at the first couple of rows, what do you notice? Since we ordered the numbers from least to greatest, any repeating values will be together. You know what would make this data even clearer? If we knew exactly how many times each value appears. That way we can easily tell which values appear most often and which values appear less often. How can we keep track of how often each value occurs? Pause now to jot down some strategies. Maybe you said we can count or tally up how many times each number occurs. That could work great. And we can even organize that into a new table. Let's do a few together. We'll count how many times each value appears and put it in this table here. How many times does 0.5 hours appear in the data? It appears 4 times. So we'll record that on the new table. How many times does 1 hour appear in the data? 2 times. Let's record that. How about 1.5 hours? 3 times. Record it. How many times does 2 hours appear in the data? Also 3 times. Record that. Here's the rest of the data. Go ahead and fill out the rest of the table in your guide to notes. Resume when you're ready. 2.5 hours appears 2 times. 3 hours appears 3 times. 3.5 hours appears once. 4 hours twice. And then 4.5, 5, and 5.5 hours each appeared once. 6 hours appeared 2 times, and 6.5 to 10 hours each appeared once. And here's the final table. Another word for how many times something appears is frequency. That being said, we just created a frequency table, which is a table that shows how often each category appears in a data set. A frequency table has a category column, which are the hours in this scenario. Categories can be numbers or words, depending on if the data is quantitative or qualitative. Categories can also be intervals of numbers, which you'll explore in an activity later. A frequency table also has a frequency column, which shows how many times each category appears in the data set. In this case, it's the frequency of each number of hours, or how many people reported spending that many hours a week on physical activity. We can analyze this frequency table to make some valid claims about the data. Be sure to follow along by filling in the blanks in your guided notes. What is the most common number of hours of physical activity per week? 0.5 hours, which appears 4 times in the survey data. What's the second most common number of hours? This one's a tie between 1.5, 2, and 3 hours, each of which appears 3 times in the survey data. Now that we have some valid claims, let's use them to make some inferences about the data. Since the most common number of hours in the representative sample is 0.5 hours, what can we infer about the population, the people in the town? Pause now to jot down an inference and come back when you're done. Since a representative sample aims to reflect the characteristics of a population, we can infer that the most commonly reported amount in town will be 0.5 hours of physical activity per week. We might also infer that most people in town don't prioritize physical activity, or that most of them have office jobs that aren't physically demanding, or that the town doesn't have enough places dedicated to physical activity. Remember that inferences may or may not be true because they go beyond what's directly being shown in the data to draw a conclusion. Based on these 4 inferences, which one is the most reasonable? It's more reasonable to infer that the most commonly reported amount in town will be 0.5 hours of physical activity per week than to make conclusions about priorities, job types, or town infrastructure. Numerical data is valuable, but visual representations might provide clearer insights into patterns and trends that we might not see in frequency tables. This is where the dot plot comes in. A dot plot shows the frequency of categories using dots placed on a horizontal x-axis. To create a dot plot, we first create the horizontal x-axis. The axis shows the data categories, which could be numbers or words. For our data, what should we put on the x-axis? Since our data deals with numbers in 0.5 increments, the x-axis serves as a number line from 0.5 to 10 scaled by halves. What should we label this x-axis? Number of hours works. In dot plots, a y-axis is optional, so it's up to you if you want to include one when creating a dot plot. For our data, the y-axis would represent the number of people. We'll use dots to represent our data. Each dot represents one occurrence of a data point within a category. In our scenario, each dot also represents each of the 30 people we surveyed. Let's start with 0.5 hours. How many dots should we put above 0.5? Since 0.5 hours occurred 4 times in our data, there will be 4 dots representing the 4 people who said 0.5 hours on the survey. How many dots should we put above 1? Since 2 people said 1 hour on the survey, there will be 2 dots above the 1 on the dot plot. If we complete the entire dot plot, how many total dots should be on the plot? Yeah, 30 dots representing the 30 people surveyed. Go ahead and complete the dot plot for the rest of our data. Pause now and resume when your plot's finished. Since the frequency column shows the number of people, it tells us how many dots to plot above each number of hours. Your completed dot plot should look like this. Why wouldn't there be any dots above 8.5, 9, and 9.5 hours? Right, none of the people we surveyed reported those hours, so it'll just be empty on the dot plot. Let's give our plot a title. And there you have it, our final dot plot with 30 dots representing the 30 people surveyed. So, do you like the frequency table or the dot plot? They both have their own strengths. A frequency table allows us to quickly see the exact frequency for each category, while a dot plot helps us immediately see the most frequent category, but also if there's a cluster, which is a group of data points close together. Do we see a cluster in this dot plot? It seems that most of the dots are from 0.5 to 3 hours. What's a valid claim we can make about this? We can say a majority of the people in the sample spend 0.5 to 3 hours on physical activity per week. Now, take a moment to write 2 inferences based on that valid claim. Pause the video now. The most reasonable inference is that most people in town spend 0.5 to 3 hours on physical activity per week. An inference that's less reasonable, but still an inference, would be that most people in town are not very physically active because of weather conditions, which limit outdoor activities. While we were exploring frequency tables and dot plots, Mia surveyed 20 people on their favorite month of the year, and now she wants you to help her create a frequency table and dot plot to represent the data. You can apply what you've learned in this lesson to help create those in the activity after your guided notes. And be sure to scan the QR code to check your work. See you next time.
Hey, hey.